Everyone, this is a preview of what we're going to see on Monday. That'll be week 3, day 1, and we're going to cover electric circuits part 2. So if you recall, we already talked a little bit about voltage, or rather circuits in general, and current. And in that context, we discussed what I called Kirchoffs junction rule. This is generally what it's called, and it represents charge conservation. And we thought about that as, for example, if you have a junction in a circuit with some current coming in and two currents going out, then the sum of those two outgoing currents has to be equal to the current going in. This is very similar to the conservation of volumetric flow of fluid that we saw in fluid dynamics for incompressible fluids. So in that sense, charge conservation acts as the incompressibility of charge, so charge is not lost, and so whatever goes in has to go out. And what we're going to see involves not current so much, but voltage, and that is Kirchoffs' loop rule, and that represents energy conservation. And we're going to see in class that what that tells us is how to relate the various voltage drops around the circuit. So here's a part of a hypothetical circuit, and you have some voltage drop across the resistance and a voltage drop across another resistance, and maybe a voltage increase due to a battery that you have here somewhere. And so wherever in a circuit you can trace a loop like this that is fully connected in this way, and you can maybe draw other loops in a different part of the circuit, that's totally okay. But for each loop that you can draw, you can always write down this type of equation. So the sum of the voltage drop here, here, and here, because they're all in the same loop, then they have to add up to 0. So that's the loop rule, and we're going to discuss that in class on Monday. And finally, we're going to see Ohm's law. It's usually known as V equals I times R. And so that means simply that the voltage drop across a resistance is related to the current by this equation. So the voltage is the current times the resistance. This works for linear resistors. The resistors are not always linear, but for the majority of what we're going to see in this course, they will all be linear, and so this equation will be valid. And as I mentioned in the announcements earlier today, this equation actually will appear on the exam. So that's the one part of Monday's lecture that will be on the exam, but not the loop rule. Although you will likely have to think about the junction rule that we saw last week. Okay, that's about it. That's all I have for you so far, and I'll see you Monday.